What's up, 11th graders? Today is Symbolic Logic, Class 8. Today's topic is the syntax of propositional logic. It's going to be part one of a two-part topic. Part one is going to be today, Class 8, and then part two is going to be Class 9 next Wednesday, assuming that we're in class next Wednesday. No reason we would not be. Now, guys, this is a topic that, frankly, we should have talked about in the first or second class of symbolic logic, but we didn't. And now we're going to, because it's better late than never to talk about what we should talk about. I will tell you, first of all, that the things that we talk about are based specifically on an article I got from Stanford University. If you guys want to look more at that article, this is really, what we're looking at today is the first section of the article. I'll put the link to the article from Stanford in the description if you guys want to look more at that to get a little bit more clarification, or if you feel like investigating more. Now, let me say this first. We're going to talk about the meaning of syntax and propositional. But first, I want to say that logic is kind of like a language, okay? And some people would say it's a mathematical language. Some people would say it's a philosophical language. I told one of you beginning of this semester that symbolic logic is a philosophy topic, and then during our first class, I was like, "Oh, I was wrong. It's a mathematical topic." Really, if you look at the programs that involve logic in many universities, you will find logic classes in the math departments and the philosophy departments. There's actually some like overlap between the classes taught in the philosophy and the mathematics departments of universities. So it's really a topic that is related to both philosophy and mathematics. And so next thing I'll say is that logic is like a language in and of itself, okay? And just like Spanish or English or any other language, the language of logic has dialects, is one way you can think about it. And we need to make sure that we are all using like the same dialect, more or less, of logic and the symbols that we're going to use to describe these logical relationships. For example, I'll just say right now, before I talk to you about the meaning of syntax and propositional, a negation can be written or described using that symbol right there. It looks kind of like a backwards L but turned on its side, right? But in other like dialects of logic, sometimes they will use a different symbol. I had it a minute ago. Oh, it was on Google. What's the symbol for negation?
Here is information from Rapid Tables.
What's the symbol for negation in logic?
Here is information from Wikipedia.
So you can see that first symbol that they have right there is the symbol I showed. But there's also a couple other symbols that can be used to describe negation. Okay, that's the point. We're going to be using this symbol. So in a sense, you could think of our logic that we're going to be using is like the dialect that Stanford speaks. Sounds kind of cool like that, especially because Stanford is like a very well-respected university. Okay, so now let's talk about the meanings of syntax and propositional. Okay, before we talk about the actual content of today's lecture. So syntax, you've heard the word syntax in linguistics probably. Syntax is really just it's just describing the arrangement of words or statements. Okay, so syntax is the arrangement of words or statements. Okay, another way to think of that is it's like the way that words and statements are organized. Okay, so we're going to be looking at the organization of the words and phrases in propositional logic. Next word we need to talk about is the word propositional. It comes from the word proposition. In Spanish, you guys know propuesta has the same root there. Think about Well, I'll tell you the definition, and then I'll give you an example. Propositional is really, when we say proposition, it's just referring to a statement about the world. Okay, exactly, a statement about the world. Statement. How do you spell statement? Yeah, I had it right. Statement about the world. And as obviously propositional would be the adjective of proposition. Yeah, propositional would be the adjective, but it's describing a statement about the world. Now, the proposition that that I'm referring to could be true or false. Okay, the propositions we look at, um, yeah, they could be true or false. Okay, and so let's jump into this. There's basically two like core concepts I want to communicate to you today. Um, Part one today is going to be more abstract, and it's going to feel like a little bit more like in the clouds, some of the things I say. And then next Wednesday, we're going to enter into some more concrete, actual examples of these different logical relationships. Okay, so here's the two main concepts I want to communicate to you today. The first concept, now when I say this, do not think linguistics. Don't think linguistics, okay? The first concept in this topic is simple sentence, okay? Don't think linguistics. Simple sentences, okay? And then the next, I'm gonna go like this. Okay, the next type of, next concept is is complex sentences. Not complex, compound. Compound sentences. Okay, so we're going to talk about the meanings of each of these. Really, when I say a simple sentence, we are talking about a proposition, okay? Something that could be true or false. Now, so a simple sentences are propositions. Okay. Now, there's another way to say propositions. It looks weird. Propositions. There's another way to say proposition, and that is, we're going to say AKA. You know what AKA means, right? Also known as, you can say a logical constant. Logical constants. Okay, so that's another way to say simple sentence or proposition would be logical constant. Okay, and sometimes you'll see it described as a proposition constant, but same thing as logical constant. Now, before I talk about the meaning of compound sentences, I want to talk to you a little bit more about simple sentences. Now, in logic, we describe simple sentences using a string of letters, digits, and underscores. Okay. Now, yeah. Underscores. Okay. Those three concepts, letters, digits, and underscores, they're like the building blocks of simple sentences. Okay. Now, notice I did not say numbers. I said digits. I said that on purpose because a digit is specifically 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Okay. 10 is not a digit. That's a number. So our simple sentences will be composed of digits, letters, and underscores. Some of you are probably thinking, what is an underscore? Underscore is, it's like if I say like Randy underscore Forsyth, that thing right there, is an underscore. You can find it on your keyboard. Okay, now a simple sentence. I was thinking right now, do I tell you this next detail? And I've decided that yes, I will tell you this next detail too. A simple sentence, or you can say a logical constant, always starts with a lowercase letter. If it does not start with a lowercase letter, it is not a logical constant. Okay, so I'm gonna go this always starts with, right? You can do that with a lowercase letter. If it starts with a number, if it starts with a digit, if it starts with an underscore, or if it starts with a capital letter, it is not a logical constant. Okay, so there's the idea of simple sentences. Now, let's look at what is a compound sentence. I'll tell you basically, a compound sentence is a logical relationship between two or more simple sentences. Okay, it's a logical relationship between two or more simple sentences or logical constants. Okay, now there's 5 types of compound sentences that I'm going to explain to you. But first, let's just write the definition. Logical relationships between, like I said, simple sentences, but in this case, I'm going to say between logical constants, referring to simple sentences or propositions. Between logical constants. Okay, now we use symbols, think symbolic logic. We use symbols to describe these logical relationships. Okay, and there's five symbols we're going to talk about. I already talked about one, the symbol for negation, and I'll tell you more about how to write that in the context of a compound sentence. Okay, now these logical constants right here. Before I tell you the 5 types of compound sentences, I want you to know that there's a word that we use to describe these logical constants. If you want to describe something that is a part of a bigger whole, once again, something that is a part of a bigger whole, we use the word called constituent. Constituent. Define constituent.
Here's the definition of constituent. Being a part of a whole.
Okay. So the simple sentences that are inside the compound sentences, each of those simple sentences are constituents. Spell constituent. Yep. Constituents. 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 Okay. Now here's 5 types of compound sentences. 1, we're going to put right here are negations. Okay. And I'm going to give you the symbol for each of these after I write them all. 2, we have conjunctions. And again, don't think linguistic syntax, because a simple sentence and a compound sentence in linguistics mean something very different than in logical syntax. Okay. Today's logical syntax, not linguistic syntax. Conjunctions. Just like in linguistics, a conjunction has a different meaning than conjunction in logic. Okay. Number 3 of 5, disjunctions. Number 4, implications. A lot of you know what implication means. We actually talked about that earlier this year. Implications. Okay. And biconditionals. We also learned about conditionals, but today's biconditionals. All right, biconditionals. Now, we don't want, when we're making logical statements or comparisons, we don't want to have to write all those words every time. So in order to save time and be able to make arguments in a more efficient manner, we have symbols for these 5 types of compound sentences. Okay, so to describe a negation, we're basically going to have parentheses and then an operator and then a letter. Okay, so here's the parentheses. And then we have the symbol for negation, okay? And then P, and then close the parentheses. This symbol right here is what we call the operator. I'm not going to write that, but just remember operator, okay? We have an operator in all 5 types. Like I said, today is a little bit more abstract. We're not going to look at much concrete content in this topic. We're going to talk about the 5 types of complex sentences, compound sentences, and then we're going to talk about the symbols for each one. And then the actual concrete material will come in part 2 of symbolic logic, which will be class 9. Part 2 of the syntax of propositional logic, which will be class 9. Okay, a conjunction is symbolized like the following: P, and then it's like a little mountain, Q. Okay, so next one, number 3, the symbol that we use is the upside down version of a conjunction. So we have again P, and then like a valley, and then Q. Number 4, implications. We're going to use we're going to start with a P. Remember, this is the syntax that Stanford uses in their logic program. At least when this article was published, is what they were using. And then we're going to have 2 lines, like an equal sign, right? Like that, and then an arrow, like that. I hope yours looks better than that, but it's like an equal sign with an arrow, okay? And then we're going to have Q. Okay, so that's the implication. And then number 5 is a biconditional, and it's going to be like this, but with 2 arrows. So P, and then there's 1 arrow, and then like the equal sign, and then the other arrow, like that. So it's like this with an arrow on both sides, and then Q. Okay, we're almost finished with this lesson because again, like I said, we're going more on the abstract route this time, and then we're going to kind of build on this knowledge in the more practical side of things, the more concrete side of things during our next symbolic logic class. Unfortunately, we only have it once a week. We've been going for 17 minutes. We'll be done before long. Now, before we finish, I want to show you one kind of a sneak peek for the next class, and a sneak peek into a more complex way to describe these relationships. Okay, and that is I could give you an example of a logical statement by saying the following. I could say parenthesis P disjunction Q implies R, and then close the parenthesis. I don't know why it's so hard to write that arrow. I was practicing before the video writing this, and the arrow looks so ugly. I don't know. Okay, so let's talk about really fast how to speak this out correctly, how to describe this logical statement correctly. Okay, so remember, this symbol right here refers to disjunction, right? And then we have P and Q, and then this right here refers to implication, or the verb. This implication is a noun, so the verb would be imply, right? To imply, and then R. So to say this correctly, we would say the disjunction of P and Q implies R. Once again, the disjunction of P and Q implies R. Okay, that's as concrete as we're going to get this class. Now, if it feels like kind of in the clouds and abstract, it's supposed to feel that way. Don't feel stressed because we haven't looked at the practical, concrete examples yet, and that's okay because we're going to talk about that next class. So here's your homework. Listen closely. Today, before 8 o'clock p.m., today's Wednesday, today before 8 o'clock p.m., you need to send me, let me move this. Today before 8 o'clock p.m., you need to send me an audio message, not video, just audio on WhatsApp, okay? Or you can send it to my email. And in your audio or on WhatsApp or email, you need to give me a summary of what I just taught you. Okay. And once again, I don't want you to read it or memorize it. I want you to speak intelligently. If I can tell that you're reading in the audio, and I'll say, were you reading that? And I might not be able to give you points if it sounds like too like programmed, right? Because I want you to speak intelligently about this. You can have your notes or this video in front of you when you are recording the audio. Now, last thing about the audio, your audio has a time limit, okay? It needs to be between 40 and 60 seconds, okay? 39 seconds, 0. 40 seconds, good. 60 seconds, good. 61 seconds, 0, okay? Cool, I think that's all clear. I look forward to listening to your audios tonight before 8 o'clock. And yeah, so that was the introduction to the syntax of propositional logic. And we will continue talking about this next symbolic logic class for part 2 of the syntax of propositional logic. Thank you guys for your attention. Hope you have an awesome Wednesday. And we will see you tomorrow for physics class. Tomorrow our physics class is at 9 o'clock. So see you then. Have a great day.